Good day everyone, my name is Oswagu Samson Ikedinachi. Chemistry Hangout is the best channel I can ever recommend for any student who is wanting to write WAEC, NECO or JAM. In fact, it is the best channel. It really is the best channel because it really helped me a lot. It helped me a lot in my WAEC and my NECO. I wasn't good in chemistry at all, but when I joined this channel and I listened to some kind of teachings over the channel, I really loved it, and I can say it really helped me a lot. It really did. It helped me a lot. So for you who is wanting to write WAEC, JAMB or NECO, I really recommend you to join this channel. And also, don't forget to subscribe. Just click on the bell button there to give you notification and subscribe.
Good day, everyone. I am Alagbe Abiodun. I'm a 3rd level student of Lagos State University from the Department of Chemical and Polymer Engineering. Chemistry Hangout has been one of the channels that really helped me when I wanted to take my JAMB or my WAEC. If you want to take JAMB or WAEC and you don't have a solid foundation in chemistry, Chemistry Hangout is going to help you to solve any problems you're having in chemistry. And I'm assuring you that you're going to get the best from it. Thank you. Please subscribe.
Hello viewers, you're welcome to Chemistry Hangouts. I want to believe we are doing fine today. Before I teach today, let me quickly say compliment of the season to all my subscribers all over the world. I wish you guys Merry Christmas and a prosperous New Year in advance. And I want to sincerely thank my subscribers. Thank you for those wonderful comments. They have been motivating. Those comments has been soothing and they serve as encouragement for us to give nothing but the best on this channel. Thank you for those wonderful comments. Thank you for sharing the video. Thank you for sharing the link. And finally, thank you for getting me to 10,000 subscribers. It's been wonderful. Thank you so much. I love your support. I love those comments. I love those motivations. And we promise to do nothing but the best. Thank you so much. Very quickly today, I decided to make this video because around some weeks ago, I received a question from one of the Nigerian universities to actually help out in solving some questions. Okay, they wanted to do their exams and they sent me that question. Of course, I have explained, I have solved it for them, but I felt that most Nigerian students that are doing a science-oriented course, okay, chemistry practical is a compulsory course you need to take in school. Yes, if you are doing any science oriented course, definitely in your 100 level you're going to do chemistry practical, you're going to do general chemistry. So I felt I should make this video so that for every other universities that will be doing a related course like that, chemistry practical course like that, they can always learn from this very particular practicals. And I've said that if you have been watching this YouTube channel, some of these questions will not be a problem because we have tackled a whole lot of questions practically. We have tackled a whole lot of questions. So I decided to make this video. Let's see how the question looks like. How can we go about it? So that for students too that are aspiring Nnamdi Azikwe University, it's a plus for you. This is the kind of question you will be meeting. And for all other students too, in College of Educations, in polytechnics, in universities, you are doing a science-oriented course, this will too will serve as reference for you, okay? So that when you have those chemistry practical like that, you can go over this channel, check how it is being solved so that you won't find yourself, in any problem. So that's the reason why we are making this video. So very quickly, we're going to be looking at the question and we're going to be looking at how to solve it. So let's see the question sent to me from that university. You can see that's why I indicated Nnamdi Azikwe University from the Department of Pure and Applied Chemistry, and the course code is chemistry 112 and it is the basic chemistry practical. So let's look at the question and let's quickly go over it. It said A is 0.100 mole per dm cube of HCl, B contains 6.0 gram of mixture of hydrous sodium carbonate and sodium chloride in 1 dm cube solution. Okay, 25 centimeter cube portion of B required an average of 22.65 centimeter cube of A for complete neutralization. Calculate molarity of sodium carbonate, mass concentration of sodium carbonate 4 into 50 centimeter cube of B, percentage by mass of sodium chloride in the mixture. Now, how do we approach this question? If you look at this question, if you have been watching my channel for some time now, if you look at this question, you see it is an alternative to practical. That's the first thing you need to know. Why do we say it is an alternative to practical? Because the average volume of acid used has been given in the question. So it has saved us from the rigors of titrating, and that makes the question to be very easy. You are not going to titrate in questions like this because the average volume of acid needed for that titration or for that neutralization is already indicated in the question, which is in fact a very easy questions for us to solve. That's number one. You already know that it is an alternative to practical. You are not drawing any table. You are not doing the practical. You are just doing the calculation strictly. I hope that is clear. Now, from there, what do we do? Because this is an A-level question. You see, it's a bit different from the secondary school question, a bit different. Because if you check this, you will be seeing, they said 6.0 gram of a mixture of hydrous sodium carbonate and sodium chloride. So you have, when they were preparing the solution, we had sodium chloride and sodium carbonate mixed together. They didn't tell us the concentration, okay? And that's the reason why they are giving us the question. So they have mixed sodium carbonate and sodium chloride together as acting now as the base. But like the O level, you are just working with, an acid and a base and stuff like that. But now you have two mixtures. You have two mixtures now reacting with HCl. I will do a video on that soon, and I will be doing the practical because this question is more or less like a double indicator practical. Yes, there is a practical that we are going to be using a double indicator where you are using your phenolphthalein and you are using your methyl. So we call it a double indicator practical. And basically what that does is that you are using, because you have two reagents now, you just have this, you have this sodium carbonate and sodium chloride. Okay, so we are using one to standardize a particular solution, meaning I want to use one of the reagents here to standardize a particular solution. So when I standardize that particular solution, and I will now use that one that I have standardized to get the concentration of an unknown sample. So that's how double indicator practical works. But we are going to make a video on that. But I'm just explaining for you to know this is a double indicator practical because it's an A-level question, so there is a form of technicality in the question. So very important now. Now, from here now, what did they ask us to do? They asked us to get molarity of sodium carbonate. Now, if you look at the question, they did not give you the equation of reaction. And that's where the problem starts. If you did not get the equation of reaction well, then you are not going to get the question at all. Okay, they didn't give us the equation of reaction, but as an A-level student, you should know this is a double indicator practical, and what will really be reacting is your HCl and your sodium carbonate. Because your HCl, if you react only HCl with sodium carbonate, it's not going to give any visible reaction. That's the truth. If you react HCl and NaCl, it will not give any visible reaction. Can you see that? So what will really be reacting will be your sodium carbonate and your HCl, which will form your equation of reaction. Then from that, you can get the sample of sodium chloride they have mixed together with sodium carbonate. Very easy like that. So the first thing is we write our equation of reaction. Let's see the equation. Let's have the equation of reaction here. Very important, they didn't give us. So we have our HCl in the aqueous form plus our sodium carbonate in the aqueous form, okay, and that's giving us our sodium chloride, okay, plus water, then we have plus our CO2 gas. I hope I'm clear. From here, let's check the equation. Is it balanced? We have two sodium here, we have one here, so we can put our 2 here to balance this. So if we balance this 2 sodium, this 2 chlorine, then we can have this. So let's check now. We have 2 hydrogen balance, we have 2 chlorine balance, we have 2 sodium balance, 1 carbon. Okay, then we have 3 oxygen here, we have 2 plus 1. That's balance. Very important. So this is the equation of reaction. Because this from equation of reaction, we are going to get a whole lot of things. So you need to get this first. This is the equation of reaction. They didn't tell you to do that in the question, but for you to get all this, you have to write the equation of reaction. Very clear. Okay? Let's continue. Number 1 now. They now ask us to get the molarity of sodium carbonate. What is the molarity of sodium carbonate in that very particular solution? If you are used to this channel, you should not find some of these things difficult. The first thing you do, I have said that, if I want to calculate molarity, that's you are calculating mole per DMP. That's the meaning of what they are saying. So I will first of all use my mole equals to mass over molar mass. Can this solve it? That's the first question you will need to ask yourself. You don't need to guess. Be sure of what you are doing. Okay, I want to get mole per dm cube of this. Do I have the mass in the question? No, because the mass I have in the question is a mixture of this and this. Can you see that? The mass is not assigned to this, but the mass there is that they have mixed hydrosodium carbonate and sodium chloride together. That's what gave them 6 grams. Definitely, I don't have the mass of this in the question. That's it. And can I calculate my molar mass? Yes, but I need to get my mole and my molar mass. You cannot be looking for two unknown at the same time, so we cannot use this. So if we cannot use this, what's the next formula that can be used? Very important, you should be familiar with this. That's our Ca, Va, plus Cb, Vb equals to Na over Nb. Let our solution be very clear. What is our Ca? That's the concentration of acid. It's given in the question, very clear. 0.001 mole per dm cube. Very clear. What is our Va? That's the volume of acid. You can see given in the question, very clear. 22.65 centimeter cube. Very clear. What is our concentration of base? That's what we are looking for. Because our sodium carbonate is the base now. That's what we are looking for, which is our Cb. We don't know it. What is our Vb? Volume of base. Very clear. Can you see that in the question? That's our Vb. That's 25 centimeter cube. Is that clear? Our number of moles of acid. You can see why the equation of reaction is important. Number of moles of acid here, we have 2. Our number of moles of base here, we have 1. Can you see we cannot slot this in this equation? So let's go 0.100 times Va 22.65 over Cb, that's what we are looking for, times Vb 25 is equal to number of moles of acid 2 to 1. From there we make our Cb the subject, then we have 0.100 times 22.65 times 1 over 25 times 2, that's 50. Can we see that now? So let's use our calculator to get what is our answer going to look like. 0.100 times 22.65 divided by 50. And that's giving us 0.045. So our Cb is 0.0453. Let's just say 45. So let's say 45 mole per dm cube. I hope this is clear. Very clear. That's our Cb now from that question. We are done with this. Now, the second one, they said mass concentration of sodium carbonate in 250. That's the reason why it's an A-level question. You have to be very, very careful. You approach it carefully and beautifully. Very important. Now, in 250. Now, the mass concentration of sodium carbonate in 250 centimeter cube of it. Let's go to the question. They said carbonate and sodium chloride in what? What they prepared is in 1 dm cube, but they asked us to get it now in 250. What do I do? So let's get this now. This is mole now. So let me convert the mole to mass in 1 dm cube that I can get for 250. Can you see that? So we can now say our mole, okay, is equal to mass over molar mass. Can we see that? Our mole. Do we have our mole now? Yes. Can you see? This is our mole. Do we have our mass? That's what we want to calculate. Can we get our molar mass? Yes, because they are giving us the atomic masses. That's it. So let's say molar mass now of sodium carbonate. That will be 23 times 2 plus 12. You know, sodium they have given us, carbon they have given us 12 plus 16 times 3. That will be giving us 46 plus 12 plus 48. And that will be giving us what? 46 plus 12 plus 48. That's giving us 106. Can we see that? 106 gram per mole. The unit is very important. So from there we can make mass the subject. So our mass is going to be mole times molar mass. I hope you are still following. So our mass will now become, what is our mole? We have gotten that 0.045 times what is our molar mass? 106. So our mass is what? 106 times 0.045. And that's giving us 4.77 gram. 4.77 gram per dm cube. Do you know why it is that? Because we are calculating this mass in 1 dm cube, which is indicated here. But that's not the question. The question says we should calculate in what? In 250. So if we have gotten the mass in 1 dm cube, then we can get in 250. How do we do that? 1 dm cube, don't forget 1 dm cube is the same thing as 1000 centimeter cube. So I can say 4.77 gram in what? In 1000 centimeter cube, which is the same thing as 1 dm cube. Then in 250, they asked me to get, which is in the question, it will be what? It will be x. Very easy. So from there, we have x, make x the subject, you have 4.77 times 250 divide 1000. And that will give us what? 4.77 times 250 divide 1000. That's giving us 1.1925. So let's just say 1.193 or 1.19. So let's say we have x now is 1.19 what gram. Decide to make it in 2 decimal. 1.19. Don't forget in 1000 it is what? 4.77. Can you see that now? So in 250, this is an easy mathematics. Why am I saying that? In 4.77 in 1000. So 250, it means that 1000 divided by 4 will give you 250. Can you see that? 1000 divided by 4, meaning it's just like you are dividing the mass by 4. So if I still do 4.77 divided by 4, it will still give me the same answer. But we are just showing this because you cannot just assume your answer or just tell us you got 1.19. That's showing us how you came about it. So that's that 1.19 gram. They have answered the second question in 250. The last question now, which is number 3. They said percentage by mass of, you can see they are bringing this now into the question. Percentage by mass of sodium chloride. We have not done anything about sodium chloride in this question. But they said we should get percentage by mass of sodium chloride. How? Let's go back to the question. Look at the mixture. Look at mixture. They said, let's do that now. Mass of Na2CO3 plus mass of NaCl is equal to 6.0 gram. This is clear. We come back here. B contains 6.0 gram of mixture of, you can see, hydrosodium carbonate and sodium chloride. So the mass of sodium carbonate and the mass of sodium chloride is 6.0 gram. Don't forget it's in 1 dm cube. And I've gotten the mass of sodium carbonate in 1 dm cube. Can you see that? Which is this. So I can say 4.77 plus mass of sodium chloride is equal to 6.0 gram. It's very clear. So from there, I have mass of sodium chloride equals 6.0 minus 4.77. So mass of sodium chloride will be 6.0 minus 4.77. Let's have that. 6 minus 4.77. That's giving us 1.23. So 1.23 gram. So the mass, can you see that? Very easy. Which means that this 6 gram we are talking about, the mass of sodium carbonate that is there is 4.77. The mass of sodium chloride that is there is 1.23. But the question says that percentage by mass. What is the meaning of percentage? In 100. We want to express their mass in 100. So how do I get the percentage by mass of what? Of sodium chloride. How do I get that? So it will be the mass of sodium chloride over the mixture times 100 over 1. So it will be mass of this, that's mass of sodium chloride over mass of the mixture times what? 100 over 1. This is clear. I hope this is clear. So from there, let me quickly finish it up here. So from there, what is mass of sodium chloride? That's, they've gotten that 1.23 over, what is the mass of the mixture? That's 6.0 times 100 over 1. Very easy. So from there, we have 1.23 times 100 divide 6.0. And that's giving me 20.5%. This is the mass. Now, how do you know your answer is even correct? If the mass of sodium chloride is 20.5. Okay, let's see. They didn't ask us that, but I'm just showing you something. Let's see the mass of sodium carbonate. So mass of sodium carbonate will now be what? Don't forget this one is 4.77. So mass of sodium carbonate will be 4.77 over the mixture 6.0 times 100 over 1. Let's see, because the 2% was at 200. So let's see. 4.77 times 100 divided by 6. Can you see that? 79.5%. Can you see that? Of what? Sodium carbonate. Why this one is of what? Sodium chloride. So can you see? With the question now, we have been able to determine the mass. So if I want to prepare this now, I know the mass of sodium carbonate in the 6 gram. I know the mass of sodium chloride in the 6 gram, which means that I have been able to use it to determine the mass. Immediately I knew the mass of sodium carbonate, okay, I am able to decide the unknown sample of sodium chloride, and that's how the question is. Can you see that? Of course, they didn't ask you to do this in the question. I'm just trying to explain. This here you stop, okay? But peradventure, they ask you to do this too, or they are asking for the percentage composition of sodium carbonate. That's how easy it is. So I want to believe we actually understand this. Please go through the video over and over again. Very important. Go through the video over and over again. Very simple. That's why when I make video like that, I make it very, very explicit. So go over the video over and over again, and I'm sure you are going to understand. So thank you so much. If you are just watching this YouTube channel for the very first time, please subscribe. You can share the video. I wish us Merry Christmas and Happy New Year again in advance. I love you guys. Thank you.